This video goes with Kuta handout number 10, and it's solving and graphing inequalities. And the first thing I want to talk about is I want to talk about how we would graph an inequality. And I'm just going to put an example up here and talk about why it is that we would do it. And let's just say that I want to graph something where x is greater than a positive 9. And if I tried to do that, I don't want to include the number 9. I want to graph all the solutions that would be greater than a positive 9. So if I come up here on my number line and I try to find something that's greater than a positive 9 but not including it, I put a little tick mark and I try to put an arrow showing all of those. Well, mathematically, that doesn't make much sense because when you think about it, the first number greater than a positive 9 would be 9.000000000000000. And I keep going on forever and then 1. And then I would have 9.00000. If you can think about infinity, and I get all the way out here, and then finally I get out there, and it's like the next bigger number would be 2. Well, there's no way I can get that close to 9 on the number line and show all the numbers greater than. So mathematically, we say, well, then there's a way that we're going to do this. You know, there's a way that we're going to show that we want all the numbers greater than 9, but not include the number 9. So I want you to put a key down at the bottom of your paper, and the key should look like this. We're going to do the 4 inequality signs. We're not going to include the equal sign. But I want to show my greater than. I want to show my less than. I want to show my greater than or equal to. I want to show my less than or equal to. And as I read inequality signs, I always read from left to right. If I see the opening first, I say greater than. If I see the point first, I say less than. And now how would I graph that? Well, if I want to graph all the numbers greater than, I don't want to include the numbers, so I'll have an open circle, and I'll go in the positive direction on the number line. If I want all the numbers less than, that means it doesn't include the number, I'll have an open circle, and I'll go in the less than direction. If I want to show all the numbers greater than or equal to, I'll have a closed circle because I want to include the number. Remember, greater than or equal to, so that shows that I'm including the number. And I go in the greater than direction. And if I want to show all the numbers less than or equal to, once again, I'm including the numbers, so a closed circle. And I want to go in the less than direction. So that key should be down at the bottom of your paper so that you can graph the solution to your inequality. So that was the first thing that I think that you need to know. And then the second thing is, of course, now we need to graph some. So I'm going to go to a different part of the handout because we did a couple examples in class that are already up here. So we have already done problem 1 and 2 as examples in class. So I want to go to somewhere in the middle of the handout and just do a couple problems. So I'm going to do 2 examples. And I'm going to do example 8 first. And I think the reason why I want to do example 8 is because it has a very good example of when we would flip an inequality sign. So first of all, we need to write it. So I have a negative 2 minus 3x. All of this is greater than a positive 7. And so there's my 7. Kind of almost looks like an inequality sign. But here's the thing that you need to remember is that you want to try to get x all by itself. But there's one rule that you have to remember with inequalities, and that's should you flip this inequality sign or leave it alone? And it's all based off the coefficient of the variable. The coefficient is the number next to the variable. You have to look at that and you have to make a decision if you're going to keep the variable sign in the same direction, or I'm sorry, the inequality sign in the same direction, or if you're flipping. My coefficient is a negative 3. If you have a negative coefficient, you know that the sign is going to flip. So I'm going to flip the sign right now. And then I'm just going to try to isolate the variable x. So I've already taken care of that rule. And remember, only the number that you look at is the coefficient of the variable. And if it's negative, you flip. If it's positive, you leave it alone. And then everything else remains the same. I want to get x all by itself. I need to get rid of the negative 2 or the coefficient negative 3. We've talked in class that it's always easier to save the coefficient for last. So what's the opposite of a negative 2? Positive 2. Positive 2 on each side of the inequality. I want to sit there and draw my sum line and simplify. Negative 2, positive 2 cancel. I still have a negative 3x. You can flip the sign now if you want to. That's all going to be less than 7 positives and 2 positives is 9 positives. How do I get x all by itself? What's the opposite of multiplying by 3? Divide by a negative 3. Remember, a negative divided by a negative makes a positive 1x. Got to divide by a negative 3 here. And so what is my solution? X has to be less than 9 divided by a negative 3 is a negative 3. I'm going to go ahead and circle my solution. And now I need to graph it. Remember, when I graph, I have to read the variable first. So I have to read x. I have to read the variable first. X, or all my solutions, have to be less than a -3. Okay, I'm going to find a -3 on the number line and draw an open circle. I'm not including the number -3, and all my solutions are less than that. So I would draw it in the less than direction. I would like to do problem number 7 now. And when I do problem 7, I have a -20. This is greater than 2p minus 2. The first thing I do is I find the variable in the inequality. It's over on the right-hand side of the inequality. So when I am done, I want p all by itself. And I want to know if I'm going to flip that sign. So I look at the coefficient of p. It's a +2. That means the sign stays in the same direction. So that's the first thing I do. If I want to isolate p, I need to either get rid of the coefficient 2 or the -2. We've talked in class about if you save the coefficient for last, it oftentimes makes the problem much, much easier. So what's the opposite of a -2? Well, we're going to add 2 on both sides. And I'm going to do a sum line so that I can simplify. If I put a -20 and a +2 together, I get a -18. I'm not going to be flipping my sign, so that's going to be greater than 2p and nothing is 2p, and a -2 and a +2 cancel. Okay, I want to get p all by itself, so what's the opposite of multiplying by 2? Divide by 2, divide by 2 on both sides of the inequality. 2 over 2 is 1, so there's my 1p. A -18 divided by a +2 is a -9. So I have my solution. Now, you could read it like this, like we traditionally read from left to right. You could say a -9 is greater than p. But when you graph an inequality, it's always easier to graph the inequality if you read the variable first. P is less than a -9. I can read backwards. P is less than a -9. So remember, I don't want to include the -9, so I'm going to have an open circle. And I want all my solutions, all the possible numbers that I could put in place of p have to be less than a -9. So I graph that in the less than direction.